Okay, thank you. Uh, wait, did you allow the screen sharing? Do you have an option to like enable the screen sharing? Because I cannot share.
Yeah, could you share with us, yeah, how to share the screen in Zoom? Oh, you found it? Oh, share screen. Okay, yeah, okay, yeah. Let's try more. Yes.
Oh, thank you. Could you please click the present button of this slide
Let me try this.
on the
Yeah,
top right?
I found it. Yeah.
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 Okay, so now we're gonna review the triangle congruence class today. So next slide, please. Next slide, please. Oh, okay. There are types of triangle we need to know first. Like by if we classify them by sides, we can classify them as equilateral triangle, which has three equal sides, and isosceles triangle, which has two equal sides, and scaling triangle, which has no equal sides. And if we classify them by angle, we can classify them as three triangles. The first one is acute triangle, which has all the three angles that are smaller than 90 degree, and right triangle, which has one 90-degree angle, and and the obtuse triangle, which has one angle which is greater than 90 degree. Next slide, please. Okay, so we are briefly going over the types of the triangles. So first, notice that this triangle, three of the angles are all less than 90 degree. So this is an acute triangle. And notice this triangle is very elegant and very unique because it is because it has one 90-degree triangle, one 90-degree angle, and it also has uh, equal two equal sides like this two. So it is a right triangle plus an isosceles triangle. And notice this triangle, the third one, it has one 118-degree angle, which is larger than 90 degree. So this is an obtuse triangle. So this triangle, the fourth triangle, it has this is also a very unique and elegant triangle because it has all three sides the same length, and also the three equal angles. Uh, so this is an equilateral triangle, and only equilateral triangle has like 360-degree angles. And the fifth one, it has 190-degree angle, so it is an right triangle. It is a right triangle. Uh, and and the last one, it has one 104-degree angle, which makes it an obtuse triangle. Next slide, please.
Excuse me. So I will bring some updates information for you guys. So the first thing that start with next week is our lessons will be short to 40 minutes each week. So make sure you guys like record in 40 minutes. And another thing is that we will use like different Zoom link, just like for today, you will use like this Zoom link, so on for the rest. And another thing is that, so don't forget to update your volunteer hours, because we're gonna like do our second report to Yu Lao Shi again in like next few weeks. So I'm gonna tell you guys when to report your volunteer hours. So be sure to participate with our like Twitter's meeting in weekends. Maybe I'm gonna have a meeting on this Sunday or next week, because next week everyone was finished their AP test. And yeah, and be sure you guys to rotate to I want to give like the chance to other Twitters also, but Roger, you did great job, so just rotate you guys. And yeah, do you guys have any questions to ask me or no?
Okay, so Stephen, can you present this slide?
Yeah, sure. So there are some sets of important angles when you have two parallel lines that are cut by a transversal. So first, there are vertical angles, and those are ones that are sort of, I guess, opposite to each other. So in this case, there's angles 1 and 4, angles 2 and 3, angles 6 and 7, and angles 5 and 8. And then there are corresponding angles. So basically, you sort of have like, the top half, like the angles in the top half and angle in the bottom half. And the corresponding angles are the ones that are sort of in the same or corresponding positions in each half. So in this case, it would be angles 1 and 5, angles 3 and 7, angles 2 and 6, and angles 4 and 8. And then there are alternating interior angles, which are angles that are in the inside of the two parallel lines and that are on the opposite sides of the transversal. And these angles are angles 4 and 5 and angles 3 and 6. And alternating interior angles have are congruent. And then we have alternating exterior angles, which are angles that are outside the two parallel lines, and they're on opposite sides of the transversal. In this case, angles 7 and 2 and angles 1 and 8. And alternating exterior angles have are congruent as well.
Could you continue? Next slide, please. Janet? Hello? Okay.
Okay, so like, should we give them some time to work on the problems, or do we just?
I think we can just like give like 30 seconds because this is a recording.
Yeah, sure. Okay. Okay, so for number 1, the relationship between angle 1 and 3, you can see that they're directly opposite of each other. So in this case, there would be vertical angles. For number 2, what is the relationship between angle 2, 4, and 5? 2, 4, 5. Okay, so we see that the angle 2 is directly opposite to the whole angle, like the sum of the angles 4 and 5. And we know that vertical angles are congruent, so we can have that angle 4 plus angle 5 equals angle 2. Now, what is the relationship between angle 3, 4, 6? So we can see that angle 6 is an alternate interior angle with the big angle of 3 and 4. And we know that alternate interior angles are congruent. So therefore we can have angle 3 plus angle 4 equal angle 6. And now what's the relationship between angle 2 and 11? So we can see that angle 2 and angle 11, they're in the corresponding positions in the two halves, so they're corresponding angles, and corresponding angles are congruent.
Next slide, please.
Can I do this section?
Yeah.
Okay, so there are more things that we need to know about angles. First, the concept of the right angle. The right angle means the angles that measures 90 degrees, of course. And the complementary angles are two angles that add up to 90 degrees. And the supplementary angles means there are two angles that add up to 180 degrees. And the adjacent angles means two angles that they are share a common vertex, which means they are share as a common side, and side up as, and they do not overlap. Just like the graph here, this is a adjacent angle, and this is a complementary angle. This is the supplementary angle. Okay, next slide, please. Okay, so there are some questions about those angle relationship. So you can pause the video and do those questions. So for those two angles, obviously they add up to 180 degrees, which means they are supplementary angles. And for these two angles, they add up to 90 degrees. Here, they add up to 90 degrees, which means they are complementary angles. And for these two angles, surely they don't add up to 90 or 180 degrees, so they are adjacent angles. And for these two angles, they are complementary angles because this is a 90 degrees, a right angle, because this angle is supplementary with this angle. So we can know that the B and A angle are complementary angles. Okay, next slide, please. Okay, so there are more questions about finding measurement. So pause the video and do those questions. Okay, so for the 14, the B is 46 because it's the vertical angle of this angle. So they share the same measurement. And for this, the 15, the B angle is 51 because it's a complementary angles with the 39 angle. So you just need to minus the 90 by the 39. So it should be 51. Yeah, 51. And for the question 16, the angle B is alternative interior angle with the 85. So the angle B should be 85 degrees. And for the question 12, the angle B is the alternative exterior angle of the 60 degrees angle. So it should be 60 degrees. And for the question number 11, the B should be, sorry, the B should be 25 degrees because with the 65 angle, 65 degrees angle, it's a complementary angle with B. Okay, next slide, please. Can somebody else do this?
Maybe I can do. Okay, there are some important rules in like determining the congruency of the triangles. So the main rules are three: SSS, SAS, and ASA, which represent like S represent the sides and A represent angles. So basically, we can determine that one triangle is congruent, which is the same to to another. By first, if three of them, like if all three of their sides are the same length, they are the same. And the second situation is that when the angle between two equal side lengths, they are also equal, like it also equals to the others. Like they need to correspond to each other. For example, this side must correspond with this side, and this side must correspond with this side, and then we can say this angle correspond to this angle. That is how we do SAS. But if I say this angle correspond to this side, correspond to this side, and this side correspond to this side, and this angle equals to this angle, this cannot determine that these two are the same because there are situations that they are not equal, but the three of the factors are equal, but we are not gonna like develop here. So the third situation is that if one side, like if one corresponding sides is equal and two corresponding angles, they are also equal. The two triangles are the same, but here it's a little tricky because here I can also say if this correspond to this and they are the same, and this correspond to this and they're the same, and wait not if this correspond to this and they are the same, and the two angles they are the same. If I say this, they are like the two triangles are also the same. This is quite different from the SAS. So AAS is like it is largely almost it is the same as ASA, and RHS, also known as HL, means this only applies in right triangles. So when there is a right angle like this, you only need two side lengths to be equal to determine that two triangles are the same, like this. This is very convenient, but it only applies to the right triangles. So here is how SSA is not sufficient for congruency, because like we usually use the congruency to draw a triangle using the compass and a ruler. So a compass is something you use to draw a circle. So like this, you can also, if you say SSA is a situation that can determine congruency, you can also say like this side is also equal to this side, but like there are two situations we can draw here. And this triangle is obviously not equal to this triangle. And that is how SSA is not sufficient. Next slide, please. Okay, so now we're gonna practice how to identify the congruency of triangles. So first, we need to know what is this mark. Like this mark means that because they both have three little lines. So they so they it means that they are of the same length, and and this is like these two are the same. These two are also the same. So so this constructs an SSS, so they are the same. And we take a look at the second one. The second one, we know that this angle, like the bottom left angle, is 100 degree, and this is also 100 degree. And also, the two sides that kind of uh kind of sandwich this angle are 4 and 5, like this. So the two triangles are the same. Like if we change the situation a little, for example, if I say this is 4 and this is 5, the situation is not changed. It's not changed. It's just like it's just you cannot it will be harder for you to identify it by using your naked eye, because uh it's flipped, but it's still the same. Next slide, please. Okay, we're not gonna do all the practice here. We're just gonna pick some practices. Like we're gonna do this one, and this one, and this one. Okay. So for problem two, we have one shared side like this, one shared side, which means like Pn equals Pn, and then we have like a pair of equal lengths and a pair of equal lengths. So we have three pairs of equal lengths. We have SSS, so they are the same. So we look at the problem 4. Um, notice that even if like it looks really like a rectangle or a square, but since the question didn't give you any hint that they are, don't assume they are. So first we know that here is a shared side, and then we know that here's a pair of equal angles, and here's another pair of equal angles. So then we know that this becomes the situation of ASA or AAS. This doesn't matter. Like, so they are the same. And we look at the question 6. they have one shared length, and then they have a pair of equal angles, and side ON and PN sandwich this angle, and it's the same for this, and then we know that like ON equals to NQ. So this constructs a SAS. Therefore, the two triangles are the same. And then finally we look at the problem 8. So they have one shared length here, and then a pair of equal triangles. Once again, although this looks really like a kind of a right triangle, a pair of right triangle, since the problem didn't give you anything, don't assume it. And then here's another pair of equal angle. So this constructs a ASA. So they are the same. Next slide, please. Stephen, can you continue?
Yeah, sure. So there are different, I guess, reasons to say that like something is congruent to another. So we have the reflective property. So that's like, I guess you just flip or reflect a line or a shape, and that would be congruent. And then there's the midpoint where you have like, the same, two things have the same midpoint, and that would be congruent. And then there's the perpendicular bisector. And so if you put the perpendicular bisector through a line segment, then if you use any point on the perpendicular bisector to create and connect it with the endpoints of the line segments, it will create two perpendicular triangles. And then you have corresponding CP, C, TC, which is corresponding parts of congruent triangles, are also congruent. That's sort of the same reasoning when we had corresponding angles, essentially. Next slide, please. And yeah, here, I guess, are the examples of the proof. Okay, so let's look at number 1 first, so the one at the bottom right. So we have AB congruent to CD, and AD congruent to CB. And we want to prove that angle A is congruent to angle C. And so first, we list what is given, and then we know that BD is congruent to BD because it's just the same line segment. And then from that, we know that triangle ABD is congruent to triangle CDB because 3 sides are congruent. So by SSS, their triangles are congruent. And so therefore, the corresponding parts of the congruent triangles are congruent, which gives that angle A is congruent to angle C. And then if we look at number 2, so on the left, we have this BM is angle bisector of KBT, and BM is altitude of KBT. So we know that angle TBM and angle KBM are congruent because that's angle bisector. And we know that BM is perpendicular to TK because that's altitude. And we have angle TMB congruent to angle KMB because perpendicular lines form congruent right angles. And then we know that BM is congruent to BM because it's the same line segment. And so therefore triangle TBM is congruent to triangle KBM due to ASA. And so therefore BK is congruent to BT because they're corresponding parts of the congruent triangle. And now we look at number 3, which is on top right. We're given that N is midpoint of MO, LM is congruent to OP, and LN is congruent to PN. So we want to prove that angle MON is congruent to angle OPN. So first, we have MN congruent to NO because that's the definition of midpoint. You know, the midpoint cuts the line segment into 2 congruent halves. And then from that, we already know that triangle LMN is congruent to triangle PON because the 3 sides are all congruent. And so therefore, we know that angle MLN is congruent to angle OPN because corresponding parts of congruent triangles are congruent. Next slide, please. Or can someone else go over this?
Sure, I can do it. Here we are looking at some more complex problem. So this question, given that the line AB, sorry, 1 minute. The line AB is congruent with AE, and the line AD is congruent with AC, and the BAD angle, this angle, is congruent with EAC angle, which is this angle. So it, and the AH is the altitude. So it asks to prove that ABC congruent to AED, and the BH is congruent with EH. So you can pause the video and try to do this problem by yourself. Okay, next slide, please. Okay, so this is the answer for proving the ABC and ADE congruent. We need first, because the BAD and EAC is equal, is congruent, and the ABC and ADE, they share the same angle, DAC, which is this angle, this DAC, they share this angle. So we know that the BAC is equal to the EAD. Then the problem description gave that AB equals to AE, AD equals to AC. So this is SAS. In this way, we can prove the ABC is congruent with AED because the SAS. So for the for prove the BH and HE. For prove the EH equals to HE, actually there's 2 ways to prove it. Because the AB equals to AE, so this is a isolated triangle. And the altitude will divide this triangle to 2 congruent and equal parts. So we know that the because the AB equals to AE and the ABH and AEH share the same side, which is AH, and the angle here is 2 right angle. So we know that the AEH is congruent with the ABH. So these two congruent angles, the BH equals to HE. Okay, next slide, please. Can somebody do this?
Okay, I'll do this. So first, we need to know what is the conditions given. The first condition given are first AB equals BC equals AC, which indicates that this triangle is a equilateral. So what we know about equilateral, it is, as I said before, like all three of its angles are 60. And then we know AE equals, wait, I shouldn't use this. AE equals CD. So now we're asked to prove ABE is congruent to CAD. First, we mark these triangles. Like this one and this one. So an important thing to know is that BAE equals C, which is 60. And this becomes easier when we know this because, and then we know that AB equals AC. And then we further know AE and CD, they are equal. So they sandwich a same equal angle. So we can easily know that ABE is congruent to triangle CAD. So we solved the first problem. And then problem B, part B, ask us to find the degree of BFD. So this becomes very hard because it is also not that hard because like obviously BFD equals to AFE, but how do we know the degree of AFE? So it looks weird, but one way we can simplify this question is actually we can redraw this triangle like this because the question only says AE equals CD, but it didn't give us the length of them. So we can assume that like CD equals 1/2 BC. Like we can assume them because the question didn't limit us. Like this. So if we do this, this will be a right angle, and here will also be a right triangle, and this will be a bisector. Here, a bisector of this angle. So here will be 30 degree, and then here 60 degree. So this will be 60 degree. However, this is just a shortcut to do this. Like a normal way we do this is use algebra. Like we know this condition before, so we know a lot. We assume that this is alpha, and this is also alpha because they're congruent. And then this is 60 minus alpha, and then so when this is 60 minus alpha, this is alpha. And remember that the sum of all three angles in one triangle, it sums up to 180. And with like 60 minus alpha plus unknown angle like this. This is unknown angle. It is 180, and we eliminate this part. So we know the unknown angle is 120. So this is 120. And then because they're on the same line, this is 60, and this is also 60. So angle BFD equals 60 degree. Next slide, please. Let's see the answer. Uh, yeah, basically, it is that simple. So you can take notes of this. So this is pretty much of this problem. Next slide, please. So we're not gonna spend too much time on reviewing this class because I wanna continue to the logarithmic lesson like we learned before. So Jenny, can you switch to that slide?
Which slide?
The slide I sent you in the Zoom. Could you like exit this slide? Could you press escape? Oh, okay. Maybe we can talk a bit.
Yeah, I can share that control to you. You can. I'm not sure, Jenny, how which link.
Could you open the Zoom? I sent you the link. Maybe you should exit the screen sharing first.
Okay. Which one? Which
The
one?
link I sent you.
Which one? 7:32 p.m. That one?
Yeah.
Okay. Okay, I can share. And okay. Probably.
Yeah. Could you present it? I press the present button. Okay. We're gonna only talk a bit about this logarithmic class because we only have like few minutes left. Could you continue to the next slide, please? Okay. We're gonna go over the definition of the logarithmics. So logarithmic is a mathematical function that denotes the inverse of exponential function. So basically, it's to determine how many times it powered, like how many times a number powered. So we need to remember it uses a log symbol, and the argument is the base raised to the power of the exponent. So we translate to human language as that it is the same to like the picture shows on the right. Next slide, please. So here are the graphs of log and exponential. So there are each other's inverse functions, which means that if you change the y to x, like if you switch the x and y in the exponential function, you get the logarithmic function. It is that magical. And then like what we want to know is the slope of the logarithmic functions. So basically, the larger the basis, the smaller the slope will be. The logarithmic function will be like this is something very important, but this only applies to x larger than 1 because it is the inverse wait, oh, I mean, it's the same. It doesn't matter. So it is also like the slope of the larger base logarithmic functions. They are also smaller than the smaller base logarithmic functions. Like that is pretty much the same with the exponential functions. That is not the same with the exponential functions. Like for exponential functions, the slope is smaller when the base is smaller. So next slide, please. So the graph of logarithmic functions tells us that all three functions, like all the logarithmic functions, go through 1, 0, this point, and all three functions, they are concave down. However, one thing I must point out is that this only applies to base that are larger than 1, and if it's smaller than 1, it is concave up. All the functions with base larger than 1, they're reducing their slopes as x getting bigger, and all three functions are negative when 0 when x is between 0 and 1, and this is the opposite when a is smaller than 1, and all three functions, they are increasing, and this is the opposite, which means it will decrease when a is smaller than 1. So I think the time is up, so we can just end the meeting here. We will continue to review this probably next time. So thank you for coming.
Yes, thank you. So we just stop.